So we're going to go through and we're going to use a p-value method to determine whether or not we have the ability to reject a null hypothesis or not. So we're going to go ahead and try this test out. So what is our test? Here's the procedure. We're looking for a one mean z-test. Now remember, the z-test was associated with that normal probability distribution, so there's going to be occasions where this is appropriate and not. But we're going to assume here for this description that that we're using an appropriate distribution for our sample. So let's perform a hypothesis test for a population mean. We're going to assume that we've got a simple random sample. It comes from a normal population or a very large sample, and the standard deviation for the population is known. All right, so what's our first step? Of course, is to write our null hypothesis and express an alternative hypothesis. Our null hypothesis, remember, is always expressed in the form mu is equal to some set mean value, mu0. The alternate hypothesis, however, depends on our situation, depends on the description of the problem, or depends on what we're looking to show. It could be a two-tailed test, in which case mu is not equal to the given mean. It can be a left or right-tailed test where the mean is either less than the given mean, or we're trying to prove that it's greater than the greater mean. We're going to decide on our level of significance. Again, this depends on how much strength of your significance test do we really need. Sometimes a lower level of significance, right? A smaller value for alpha means a much more expensive and probably more detailed test. And there's a couple of other practical considerations, but we're going to decide on that level of significance, and typically we say, well, for a 95% confidence interval, we would say that alpha level is 5%. And that's sort of a standard acceptable way of doing it, unless we have more information. Step 3 is to compute the value of our test statistic. So we're actually getting a z-value right here. And that z-value is we're either going to go with our z-value and use our critical value test, or we're going to find the probability associated with that z-value from our table, and then find whether or not that p-value meets our p-value approach. And that's actually the approach that we're using, the strength of the test for our p-value test. So step 4, if we were using the critical value method, that would mean that we were actually looking to see whether or not we reject based on whether or not our z-value is less than the z of alpha over 2, less than the z of alpha if it's a left-tailed test, or greater than z alpha if it's a right-tailed test. And to show you what that means here, let's just quickly we'll go to an example on this one. Let's say that I was given a value obtained from a test statistic for z in a one mean z-test. Given that the test is left-tailed, let's determine the p-value. Well, we could determine the p-value. We'll do that here in a minute. But would we reject this based on that critical value method? Well, in our case, if we have a 5% level, if our p-value is 5%, so we're using p-value 0.05. That's also our alpha level, right? If alpha is 0.05 in a left-tailed test, we're going to associate that with the value of z equaling negative 1.645. If we have alpha at 0.025, if that were the case right here, our z-value would be negative 1.96, right? That's our two-tailed test. But we're interested in this one right here. So we test to see whether or not that z-value is less. Well, in this case, the z-value of negative 0.74 is not less than our z associated with our alpha, right? Z alpha right here. So no, we do not reject. We do not reject. We do not have enough evidence to reject. How about right here, 1.16? Well, for a left-tailed test, definitely not, right? Now, on the other hand, if we got a z-value that was less than negative 1.645, we would reject, right? If we got a z-value of negative 2, for example, that would be the time to reject. But in this case, again, we do not have enough value to say that our z value is less than the z alpha that we chose right here. So let's go back now. The other value, the one that we're going to use here, and we're going to show the Excel program in which we deal with this, is to use our p-value test. And the p-value, what we're looking to see is if whether it's a two-tailed test or a one-tailed test like these ones, we're going to reject the p-value, the null hypothesis, if our p-value is less than alpha, less than or equal to alpha. Otherwise, we don't have enough evidence to reject. Now, the null hypothesis, the hypothesis test is exact for normal populations and for approximately correct for large samples from non-normal. So what do we mean by large samples? Well, let's specify now. For small samples, let's say that we have less than 15, this description should look familiar to you from last week. The z-test can only be used if we know that it's coming from normally distributed distributions. If it's not, we can't use this. For samples of moderate size, somewhere between 15 and 30, we can use the data unless the data contains outliers or is far from being normally distributed, right? If we have a distribution that is not normal, then we can't use this test. Now, if the sample size is 30 or more, that's considered a large size sample. The z-test can essentially be used without too many restrictions right here. We look to see if there's outliers, and if those outliers are affecting it, then we might want to consider how we're looking at our data. But if outliers are present and their removal is justified, we should remove them before using that z-test. If, remember, the principle is that if one of these rules is violated in even a small way, we should not use that test. All right. So we've talked about this right here. Let's say that are we ask the question, are we justified in using a z-value test for this following description? Well, we did preliminary data analysis and we revealed that the sample data contains no outliers, but the distribution of the variable under consideration is probably highly skewed, and the sample size is 24. What do we say? Well, this is a case where our sample size is less than 30, right? So it's not a large size sample. This is sort of a moderate size sample. And in that moderate size sample where we're between 15 and 30, well, there's no outliers, but our data set shows that it's probably highly skewed, right? So that's a non-normal distribution, and therefore, based on this description, no, a z-test is not justified. All right, so we would want to avoid using that in this case. All right, so we want to know those reasons why we would or would not use these particular distributions. All right, now having said all that, let's get to a test. Let's assume that we've gone through and we've discovered all of our information is coming from a normal distribution. We've got a sample size that, while small, comes from a normal population, and we know that the population standard deviation is 4. So let's perform our hypothesis test. I'm going to show you how we're going to do this using our Excel program. So let's go to our desktop and let's enter in this information right here. Since it is a z-test, we're using it for a moderate size sample where the data contains outliers, but it's far from being it's normally distributed. We're going to go ahead and enter our information right here. So this is the way that we enter the information in our program. To do this, we put in our null hypothesis mean. The null hypothesis mean was that the population mean was, the claim was that it was 22. And our alternate hypothesis was that the mean was not 22. So this is a two-tailed test. So we're going to go to, we select C right here to indicate that that's what we're looking at as far as our null hypothesis. Well, what do? We're going to put in our sample size. Our sample size in this case was 24. We found a sample mean of 23, and our standard deviation for the population, that's sigma, that's 4. Now we wanted to test this at the 95% confidence level, right? And this is a two-tailed test. So what that means is that we're going to have to take that alpha level of 0.05 and divide it by 2, 0.05 divided by 2, right? Because if it's a two-tailed test, right, our alpha level needs to be less than that. And we come up with 0.025. All right, now this program gives you both the z-score and the p-value, but we're looking specifically at that p-value. And our p-value of 0.221. All right, so what does that mean? Well, if we're rejecting due to our alpha level, right, and we're saying alpha over 2 in this case is what we're interested in, alpha over 2 is equal to 0.025, we're going to reject if our p-value is less than 0.025. But our p-value in this case ended up being 0.221, so we do not have enough evidence. We don't have enough evidence. That's a terrible way to spell that. We don't have the evidence to reject, right? So we fail to reject. Our null hypothesis, right? And so saying that the mean is 22, the way that we're going to hedge our bets here as statisticians, we're going to say, well, if the claim is that it's 22, we don't have enough evidence to reject that claim. So there we go. This is our test in a nutshell. All right. More to come.